Hello and welcome to Supercloud in 2023 Summit. My name is Melissa and I will be your coordinator for today's event. Please note this conference is being recorded and for the duration of the call, your lines will be listen only. If you require any assistance at any point, please press *0 and you will be connected to an operator. I will now hand you over to your host, David Rammel, to begin today's conference. Thank you.
Thanks, Melissa. Okay, welcome everyone. I'm David Rammel, editor of Virtualization Cloud Review, here to moderate our first session as well as welcome you to our Supercloud in 2023 Summit, brought to you by VMware. Before we start today's three-session event, we do have some announcements. First, we want to let you know this event is being recorded and will be available for future viewing. You'll receive an email when the replay is available, generally within the next few days. Also, each of today's three sessions will be followed by a 5 to 10-minute Q&A, so please be sure to put your questions into the Q&A area of your console as they come up so we can get them answered for you by our experts. And during today's third session, we will be giving away a Breville Barista Pro stainless steel espresso maker. But you must be present to win, so be sure to stay on for the entire event. Finally, we do have resources from our sponsor, VMware, available on the console right now, so please download and check those out. It's because of VMware underwriting the summit that we can bring you this great content from industry experts, so we thank them for sponsoring the summit and supporting the community and ask you to check out those resources so we can bring you more events in the future. Now on to the first session of today's summit. Supercloud 101, why Supercloud and why now? This session features Greg Schultz, founder and IT analyst at Server Storage IO. Greg has worked as the customer in various IT organizations in different roles, as well as a vendor, consulting analyst, and author of several books, including Software-Defined Data Infrastructure Essentials, which you can find at CRC Press. Greg brings a diverse background with real-world perspectives across applications, data infrastructures, hardware, software, and clouds. Greg is also a Microsoft MVP Cloud Data Center Management and previous 10-time VMware V-Expert. Greg, it's great to have you here. Please take it away.
Great. Thanks, David. Hello, and welcome, everyone, to today's discussion, Supercloud 101. Why Supercloud and why now? Real quickly here, and again, this is Greg Schultz from Server Storage IO, and let's talk about this. Why Supercloud and why now? But first, we've got to start out with a little bit how we got here and where are we going, i.e. with the Supercloud. And Supercloud extends the traditional cloud computing, including networking, compute, storage, architectures from core to edge, and really takes a lot of the attributes that we heard initially with cloud: elastic, scalable, flexible, adaptable, but effectively supersizes everything, for lack of a better superlative. We're going to have a little bit of fun here. But that driver is around that clouds have gotten bigger, their adoption has grown, the deployment in different aspects, and along with that has come management, migration, security, and other challenges associated with using compute-based platforms, whether they be traditional, legacy, on-prem, out at the edge, in the cloud, that there are just simply, as they scale, more things to worry about, to be focused on. And one of the questions that pops up with Supercloud is it a concept? Is it a paradigm? Is it a product? Is it a service? Is it a solution? Or is it just marketing, super whatever? Okay, well, we're going to take a look at that. And the reality is that there are different approaches, there are different products, there are different services, there is a whole paradigm. There is also a concept, just like there has been with cloud, but it's just taking it to the next layer and scaling up, but also scaling out across different platforms. Does Supercloud require cloud-native applications? No, not necessarily. And we're also going to look at what are some common challenges, as well as some approaches for securing, protecting data, and associated management tasks with Supercloud. All right, so you don't have to be Superman to be, or a super person to manage a Supercloud. And that's actually a picture of somebody dressed up as a Superman doing steeple repair way up in the air attached by a rope. It just helps set the stage for our discussion here. All right, so that big picture, how we got here, where we're going, is that we've seen the continued migration from traditional bare metal physical machines to virtual machines to cloud machines to containers to serverless services. But we've also have seen cloud platforms, in addition to supporting virtual machines, cloud machines, containers, and other compute services, actually supporting bare metal, metal as a service, such that you can layer different cloud management, different software, different solutions on top of the cloud resources without having to resort to nesting and things like that. So what we're looking at here is that ongoing, that things are going to some sort of cloud type environment, whether it be a cloud managed, whether it be a cloud management, whether it be a cloud platform, whether it be on-prem at a colo or service provider, whether that be at a public cloud, whether that be at the core or out at the edge. We're seeing this continued evolution. We're seeing the public cloud services increasing their scale, supporting more regions, supporting more availability to zones, improving their resilience, their fault containment. And what we're seeing there is that those are also scaling in terms of functionality, the feature set, the services that they have. So again, they're scaling up. They're also scaling out in terms of resource availability capabilities, but also that functionality. We're seeing that continued adoption of virtual machines, containers, leveraging serverless, Kubernetes, different aspects, particularly for cloud native. But we're also seeing the continued use of traditional workloads that are just picked up, lift and shipped, or lift and shifted from a physical machine to a virtual machine, or even just moving them into the cloud with that cloud management layer over the top of what could be a bare metal physical machine at the core of the cloud, but also continuing to push out towards the edge. So on this chart, we also see that there's the private clouds, the government clouds for government entities, that we've got edge clouds for the remote office, branch office, for edge computing, departmental or even work group for different applications, supporting IoT as well as other workloads, machine learning, AI, things like that. We're also seeing the different cloud providers with their different locations, whether it be Azure, whether it be AWS, Alibaba, Google, long list of different options. But we're also seeing at different layers, the infrastructure layer, the PaaS or platform as a service layer, also the SaaS, i.e. 365 or Office 365, Salesforce.com, different examples like that. But something I want to point out here, because we'll see this as we work through this discussion, is across the bottom, horizontal. Those are where different cloud platforms exist. And those could be at the core, they could be a public cloud, it could be private, it could be hybrid, it could be a multi-cloud, it could be on-prem at a service provider or at the edge. So think of that as the different platforms that are combining and enabling the compute, the storage, the networking, the software, all those resources together to support the different apps that sit above them. Over in that right, that vertical, those are the different layers, the focus areas. Those are the full stack, if you would, from that low infrastructure up to the apps themselves. So why we're having this discussion, it sets up for the Supercloud, which is as we have more of these different clouds, as we have these different resources spanning different services, spanning different functions with their different requirements is driving that need for the super cloud that overlays everything. And here we see this in this slide right here. What we're seeing here is how the super cloud layers across all these other entities, across your different public clouds, across your on-prem, across your core, across your edge, across different services. So that prompts the question then, is a super cloud just an abstraction layer? Yeah, it can be. Is the super cloud all about management? It can be. Is the super cloud about enabling somebody else to take control of the management space? Well, something you got to watch out for. But what the super cloud is, it is an abstraction layer. It is an overlay. It can be a product. It can be services. You can find different solutions at different layers of the stack that supports these capabilities. But what the super cloud is, its attributes, its tenets. And for some of you, this is going to be deja vu of what you heard 10, 15 years ago about the cloud computing in general is scalable, flexible, elastic, resilient, interoperable, cost-effective with automation, managed, APIs, telemetry, and more. Okay, so deja vu. That's what we heard for each of those different clouds. Now we're just taking that up another layer, putting another abstraction so that now from a management, from an operations, from a cost management, a configuration deployment, you see what effectively is a virtual cloud, an overlay, a layer of abstraction to simplify whether you're consuming, whether you're deploying, whatever that functionality is at different layers. Okay, so let's build out on this and let's dig down a little bit more and look at the different pieces that make up this, that make up the challenge around why the need for a supercloud. Why the need for that abstraction layer, which is to manage, to support, to operate, to consume, to provision, to secure, protect across the various locations, across the various platforms, across the different layers, and across those different focus areas. So looking at this, we could have there on the left a private cloud. That could be your on-prem with an edge deployment where you've got resources out at the edge with hypervisors, with containers, supporting different kinds of workloads, storage, etc., so that you're able to put processing out close to where the apps need to be, where the data exists or is being generated, more importantly, where it's being used and consumed, to all help mitigate, offset challenges with network latency and bottlenecks, things like that. But over on that left, you could have a combination of edge consuming and being made up of Microsoft, Linux, VMware, as well as even public cloud provider capabilities. It could be using traditional architecture deployments. It could be using converged infrastructures. It could be using hyper-converged infrastructures or HCI to give you that capability, and then having that connectivity to another cloud. So within that left cloud, we have the management, we have the different software-defined attributes, capabilities, we have authentication, access management, endpoint protection, managing and securing the endpoints that allow you to get into that cloud, to get to the apps, to get to the different resources, to be able to authenticate those who have access and what that level of access is, as well as protection. Okay, so that's a fairly straightforward look at a cloud, whether it be a traditional cloud or even a hybrid cloud. But now we're going to take another step, which is we're going to add another cloud there in the top right. And these could be intercloud, in other words, where you have your own private cloud there on the lower left. You're in a public cloud on that top right, and you're moving apps, you're moving data, you're migrating, you've got information you're managing across different types of clouds that have different services, different management tools, but that you're moving them across different types, i.e. what we'd call a hybrid or even a multi-cloud. But let's put another wrinkle into this, which is now we also have another cloud down on that lower right. And that could be yet another cloud provider, another service provider, and we could have inter-cloud, i.e. across different cloud services, different platforms. In other words, inter-cloud being AWS to Azure, Azure to Google, Google back to on-prem or out to the edge. But we could also have intra-cloud, which would be going from your on-prem to maybe your edge location. So think of it, inter is spanning different domains, different focus areas, kind of like internet, whereas intra-cloud is like intranet, within your environment, within your domain or sphere of management protection. Okay, so as what we're seeing here is, yeah, we've got multiple clouds, we've got a hybrid approach, but we also have these different stack layers, these different focus areas. And whether that be the servers, the storage, the compute, whether that be the services, whether that's managing containers and cloud native, and whether it's supporting them, deploying them, or developing. But it can also be running virtual machines. It could be running traditional workloads and being able to work with those. We also see that notion of virtual private services or servers, dedicated private servers, as well as bare metal being in the cloud for apps or workloads that need that bare metal, or to be able to scale at a larger scaling factor than you would with a regular container or virtual machine, but still having that cloud management layer overseeing that capability. In other words, metal as a service. Okay, so we're looking, again, horizontally across these different locations, venues, and platforms, and keeping in mind that vertical focus, up and down that full stack view. Okay, so with that full stack view in mind, let's take a look here and just reinforce, what are we talking about? Well, down at that lower level. That lower level is looking at things such as the infrastructure as a service, the fundamental building blocks, the hardware, the software, the compute, bare metal, physical machines, virtual machines, container, as well as various services. It's the storage, solid state, traditional magnetic drives, tape, block, file, object, as well as tables. It's the network, the endpoints, the firewalls, gateways, and all those things, and then along with their management. Above that, we have the platforms, the PaaS, building blocks, databases, tables, development tools, cloud native deployment, orchestration, and associated tools that go along with that. And above that, software as a service or apps. So it's just a stacking layer that factor in to this whole cloud approach, that we're going from cloud to private cloud to public cloud to hybrid to multi. Now we're just adding in another layer to tie all that and manage it together, i.e. the Supercloud. Okay, so let's take a look at the Supercloud from a little bit different perspective. Your Supercloud, as we talked about, it's that abstraction. It's that way of abstracting for management, configuration, deployment, optimization, insight, awareness, and associated capabilities. So that abstraction layer could be across everything, i.e. via management. It could be across that SaaS layer, in other words, giving you that abstraction across different tools, different services. That abstraction for the Supercloud could be across the different platforms as a service or PaaS layers. It could be across different databases, repositories, development tools. It could be across the infrastructure layer, across the different networks, hardware, software, virtual machines, container management, and different combinations of those. It could also, it being the Supercloud, it could also embrace all of those layers as one collective abstraction management tool with its associated databases, repositories for configuration, deployment, policies, templates, and things like that from different vendors. Okay, so that's a nice, neat, tidy, looking at things from a layer perspective. Now, let's look at what you might be dealing with today. Where or what is your Supercloud commonality? When I say that, is that layer where you have some commonality or something that's leaning towards a commonality. In other words, there may not be any commonality. You might have AWS on the left, right next to it you might have Azure, right next to that you might have Google, right next to that you might have VMware, you might have something else over there on that far right, IaaS layer. Go up a notch, you could have different PaaS tools and resources in each of those different boxes at each of those different venues. You might have some overlap, same thing with that SaaS. You might have different SaaS services that maybe span a couple of those columns, but others that are unique. Same thing with management. You might have different management tools for insight, awareness, configuration, for security, for data protection for each of those different columns. All right, so let's build this out. Well, you could have that common layer being that common infrastructure across everything, whether that be an AWS or whether that be a Microsoft Azure or Azure combined with various stacks and Windows and things like that. Or it could be, and then again with separate PaaS, SaaS, and management layers. Or it could be that you've got a common PaaS layer set of tools or focus that gives you abstraction across all the different PaaS components. That's abstracting what's underneath it. That could also be that you're abstracting your SaaS view, that you've simplified on those SaaS services, those SaaS capabilities, that you're able to abstract and then abstract their underlying resources. And then it could also be that there's a new management tool that just simply overrides, that sits on top of everything, that leaves pretty much everything as is, but that just has the hooks to get in and get the information, to configure, provision, different things like that, or it could be all-encompassing. So another variation on this is, now you notice I just brought in over here on the right a green dashed line. Well, that could be that you've got a management tool that overlays everything, but that also has specifics that address the IaaS, the PaaS, and the SaaS layers as part of its base deployment. This could be something like AWS with their appliances. This could be VMware. This could be Microsoft with Azure Stack and Azure Arc and other capabilities. Okay. Another variation is that if you notice now, I've added a green box over there in the center where you've got that common management capability that also supports an appliance, a software-based appliance running on some hardware, tin-wrapped software, if you would, an appliance out at the edge that gives you basic functionality of PaaS and infrastructure, but that also has that common capability back at the core cloud that gives you the infrastructure, the PaaS, the SaaS layers. This could be an AWS, this could be an Azure, this could be a Google, it could be, the list goes on. Several different options there. And again, it's all about those overlaying, those how you're abstracting that. So we've talked a lot about management. Let's talk a bit more about management, but let's dig a little bit deeper. And as we go a little bit deeper into the story, into this Supercloud, what we've got going here is why Supercloud and why now? Well, let's look at the challenges. We're across different clouds. How are you doing the availability, the resiliency, which should be one of the attributes, is that by using different clouds, you should be able to spread things out for availability, for resiliency, for data protection. But there's also that complexity of protecting across those different resources across those different platforms and the associated risks that go along with that. So as a part of that, there are the different security concerns, protecting the endpoints of those different platforms, of those different clouds, at those different locations, authenticating and giving rights and giving the ability to authorize users, to give them that authentication so that they can connect, they can manage, they can use and consume, but also be able to revoke that when need be. So in other words, to have that distributed rights management in an environment that may not be all, for example, Active Directory, where you've got different directories, different points of managing your authentication. It means being able to manage your keys, your certificates, and be able to delegate, but also revoke as need be. Okay? Again, we're looking at different geographies, which also means different governance concerns, compliance, mandates, regulatory, data privacy. You've got your buzzwords, GDPR, HIPAA, SARBOX, PCI, and so forth. There's managing the service levels, service level objectives, service level experience or service level expectation, service level agreements, as well as other things, service metrics, RTOs, RPOs, things like that. But what it all comes back to is enabling that management of configuration, deployment, be able to do costing and optimization, to support migration, whether it's supporting lift and ship or lift and shift, or conversion from one environment to another, or converting from traditional virtual machine into a container-based, into a cloud-native approach. So it's also to help with supporting the assimilation of different clouds via mergers and acquisitions, assimilating or taking over support for shadow IT and work groups. One of the questions that comes up is, okay, so we're going to put this Supercloud super layer. Where's the priority? Where's the focus? Where is it going to be managed from? What's the authoritative copy? Where and who is that? Is it one of the cloud providers? Is it a third party? Is it somebody who's playing in or across those different columns, across those different platforms, up and down that stack? How are you going to handle cross-platform coordination? How are you going to handle cross-training and skill sets across these different environments, as well as addressing budgets and risk? What about watching out for platform dependencies? So the good news is a Supercloud abstraction layer can help to isolate and mitigate being locked into an AWS or into an Azure or into a Google or into one of the others. But does it lock you into that Supercloud tool, that Supercloud framework? Something to keep in mind. How are you going to handle those migrations, whether it's a simply move or convert, and whether it's on an initial one-time or on a recurring basis? How are you going to handle patch and update management of the full stack, up and down, as well as across those different platforms? But having that timely visibility to be able to find and detect threats, find blind spots across these locations, as well as detect anomalies. Okay, in other words, you don't want to be flying blind in a cloud environment. So here are some threats. Here are some threat risks that apply to super clouds as well as traditional clouds, hybrid, multi. But there's a lot of different things that are out there that need to be protected. And one of the aspects of that super cloud is, rather than focusing in on just, say, an AWS and then focusing in on Azure, focusing in on Google, focusing in on VMware, focusing in on OpenStack, focusing in on XYZ, is that you have that abstraction that your focus, your policies, your settings, your templates, all of that can be then applied via a layer that does the platform-specific capabilities. Because you've got the common threats, you've got the added threats of new things that are always going to be coming in as well as those threats from the complexity of having all these different locations. So that's why we have these different enablers. Across the top are the different threats. Across the bottom are your building blocks as well as your security enablers. Okay? So don't be scared, be prepared. Know the threats for your organization as well as to your different apps. And what is their relative impact? Is it going to be a complete loss, a loss of access, a loss of apps or data? Is it a partial loss? Is it a destruction? Is it damage, corruption? Or is it simply a denial of service attack? Are the apps or the data compromised themselves with data theft or exposed? So know the threats, the applicable impact to the biz, the apps, as well as the data. Everything is not the same, so why treat it the same? Just like all the clouds aren't the same, don't be tied into having to treat them all the same. So detect, diagnose, defend, and be able to recover, have good backups, have protection, have that security to prevent intrusions, to detect when something does go wrong, but have those backups, that protection. And the backup could be a snapshot combined with a replication, could be a traditional backup. It could combine different granularities up and down that full stack across the different platform with the platform-specific tools. So keep a plan, keep it current, apply remediation and updates up and down that full stack. All right, so protecting, preserving, and secure. And this just goes into some detail. We're not going to go real deep on this, but just to touch on it here, we see some of the different components. There's a lot of different moving parts. And a lot of this should be pretty straightforward, should be familiar. If you're already in a cloud, if you're in a multi-cloud or hybrid cloud, it should ring a bell. We're just now taking this, and we want to be able to apply it, have a layer that can help abstract this, but then reach in to the specifics of that full stack of the different layers, focusing on the network, the endpoints, the mobile, your credentials, your settings, your keys, protecting the protection mechanism, making sure that you've got your data protection backups, that they're actually protected, that your certificates, your keys, your settings are protected. So as we move along, one of the notions around a supercloud is supercloud data protection, i.e. protecting to the cloud, also in the cloud, as well as elsewhere. And it's just really building on traditional data protection, leverages different techniques, different tools, different granularities, whether it be point-in-time copies, snapshots, checkpoints, backup restore, at different granularity, at different layers, and then using platform-specific data protection as well as resiliency, but also adding in fine grain so that, for example, you have that ability to restore an individual table versus an entire database. So this should be hopefully familiar just now that we've added that dimension of being able to apply a data protection layer that abstracts the data protection across those different platforms, from the different public clouds, the private, to the on-prem out to the edge. Okay, so some things here, some of these we've already touched on, so we'll go through these pretty quick, but think of it this way, that abstraction layer that gives you the management tools, the insights, the dashboards, but also that supports the ingestion of policies, your controls, your templates, your runbooks, your security, authentication, that takes that as input to help drive the different resources there, bottom center, that gives you that visibility, that gives you that ability to migrate and move, to detect and notify, to address cost and know your inventory and what's your spend, for providing management, automation around service level management, productivity. How are you meeting compliance and governance as well as regulatory needs, as well as how is your health and status of your apps, the data, the infrastructure, and all the different components. So building this out, timely insight, situational awareness of your super cloud, This really comes back to having that insight, having that awareness of those different layers, those different columns that we looked at earlier. Avoid flying blind. Sure, you've got tools, you've got your dashboard, you've got automation, you've got AI, you got all these great things. Those are only as good as the data, the telemetry that they're being fed along with the policies to be able to be useful. If you're flying blind in the clouds and your instruments might be good and you want to trust your instruments, but if they're getting bad data, bad telemetry, bad feeds, you could have bad results. So having that timely information being fed and being able to get that up and down that full stack as well as across is key. It's crucial. Know your cloud resource cost versus service delivery. Are you over provisioning? Are you overspending, or are you under provisioning? Maybe some apps are over provisioned, maybe some others are under provisioned. It's not about cutting costs. It should be about removing costs, but also right-sizing, optimizing so that a particular app, a particular workload gets the resources it needs to be productive for the organization. And also just watch out for, are you paying for resources that you're not using? You also want to watch out for moving things around, chasing costs, trying to save a penny that ends up costing you more. Just something to keep in mind, that there is a cost for moving things around. All right, so moving into some tips, some insights is review the security and data protection, including backup restore. How can you manage those costs if you don't know what you're doing? What are your APIs? What are your service management request metrics and cost? In other words, there's a cost to managing for doing an API query, for doing different gets to collect that information, and how are you being billed? How are you being invoiced for those? So again, it's having that insight and balancing applicable resources to that apps that we just talked about a moment ago. So again, it all comes back to having that timely insight. It's about knowing the business as well as the threat risk and that impacts, is knowing the workloads, knowing what their resource needs are, understanding that what their level of protection, what their level of resource needs are, and giving the right resources to the application so that the apps are productive, that the users are productive, that the organization is then successful. All right, moving along. A couple more tips and recommendations and reminders. Again, know your apps, know your workloads and needs. That's your inventory. That's part of your cost optimization. It's part of your configuration. Understand if you have under or overutilized resources. Again, that's part of that optimization. Are you getting effective return from your cloud resource usage? That proactive remediation, patching up and down, hopefully leveraging automation to be able to go that full stack, but across those different platforms. And enabling that security, enabling that data protection, encryption, protecting the endpoints to be able to detect, and defend. But also having that backup restore, whether it's a backup, a snapshot, such that when something happens, you can go back in time so that the business can move forward when something does happen. Okay, a couple more, and then we're going to wrap up for Q&A here. Is keep in mind that there is the initial provisioning and configuration management, but what about the recurring task? That's something that can catch you off guard if you're not watching for it. There's a lot of focus, especially with TCO and ROI models, that just look at the initial deployment, the initial management. Keep in mind those recurring costs of the hardware, the software, but also the people time to be able to manage that. And that's where those cross-platform tools come into play. The service management expectation, that service management experience, updating skills, training, having those policies and controls that can apply across the different locations, platforms, but also up and down that stack. That common theme, timely, relevant, situational awareness, avoid flying blind. All right, let's start to wrap up here. couple more notes, a couple more comments here is, do you need or do you want Supercloud? What is it? Or are you just interested in it right now? It is a new term. There's a lot of different aspects to it. As we talked about at the beginning, it can be a concept, it can be a paradigm, it can be a management approach, it can be a tool, it can be a product, it can be a service. Do you need it or do you want it? Do you require it? What do you need a Supercloud to do for you? What layer do you need it to be done at? What do you need to address? What are your specific pain points, challenges that the Supercloud is going to be the super cure for? Understand your current and emerging cloud technology and challenges. Know your biz and app requirements as well as their workload profile. Here's the thing. The best solution is the one that works for you, not one that you work for or get locked into. A lot of different options there. We're going to go more into this throughout the summit today. Where you can learn more, my main website, storageioblog.com. My books are at storageioblog.com/books.html. I'm on Twitter at storageio. My email, greg@storageio. And with that, let's bring David back in. And David, do we have time for a couple of quick Q&As?
We certainly do, Greg. We have a bunch of questions lined up. And first of all, I'd like to thank you for finally explaining what a Supercloud is to me. I read about it, and I never really grasped it, but your presentation certainly helped.
No worries.
And let's get to those questions. I'd like to remind the audience, if we can take out questions until about 5 minutes at the top of the hour in order to give you a short break before the next session. So please send them on in now. And here's a great question from Lynn in the audience. Lynn asks, what are the key challenges and barriers to entry for organizations looking to embrace the Supercloud concept? Are there any prerequisites or special skill sets required for successful implementation?
That's a great question, David. And let's break this down a little bit here, which is, are there any prerequisite or special skill sets? Yeah, you should have an understanding, hopefully an operational understanding of using clouds, of managing clouds, deploying it, whether that be with the public clouds, whether that be on a private basis, along with associated management tools technology. The other part to that is there are different approaches. So are you going to look at it from an AWS Supercloud that sits above everything else? Or are you going to look at it from an Azure or a Microsoft perspective, or from a VMware, or from some other tool set? So those are the different aspects to it. Those are some of the different considerations. It comes back to what is it that you're trying to address? What is it that you need to enable that Supercloud to do for you?
Okay, great. Looks like we have some questions here about certifications and training. So let's get to those. Here's a question. Do you know of any certifications for Supercloud?
For Supercloud specific, in generalities, not yet. Give it time and somebody will come out with a certification tied to a training program and what we normally see. Now, having said that, watch the different platform providers put out their Supercloud page with their Supercloud program, with their Supercloud certification, diploma, training, and all things that go with that. But also watch out, is it platform specific? Is it platform dependent? Is it around particular products? But you also see this coming from some of the overlay providers, whether they're already involved at some of those locations, whether it be a VMware, or whether it be a Red Hat, whether it be OpenStack, or some other tool set that'll take a look at it from those different viewpoints. The key is, right now, is understand, if you know a public cloud, learn about a private cloud. If you know a private cloud, learn about a public cloud or more, because those are really the prereqs for thinking and understanding and grasping what the Supercloud is.
Okay, great. I'd like to remind the audience that we have about 10 more minutes for questions, so please send them on in because Greg lives and breathes this stuff, so this is a great opportunity for someone to get some expert one-on-one discourse. And as I mentioned, there's a question about training. Are there additional costs and overhead as well as training for Supercloud?
That's a good question. There's a couple pieces to it. If right now you're worried about, say you've got some Azure, say you got some AWS, say you got some VMware, and then maybe you have some other providers that are giving you the data protection aspect, and maybe you got somebody else involved as part of security, maybe something else in another layer there, maybe some Kubernetes management, just to throw a couple things out there. So on the one hand, you've got the training for those different pockets, for those different platforms, for those different clouds, for those different entities. And the question comes up is, if you have a super cloud, can you abstract where you don't need as much AWS specific, Azure specific, VMware specific, data protection, or some other vendor specific? You're still going to need some people, some staff, hopefully more than one, so you don't have a single point or a single person of failure, is you should be able to reduce having to have an army of experts for that particular platform. Instead, they become more knowledgeable about that overlay, that abstraction layer. So you've got that opportunity to initially shift some of that training spend and potentially optimize that and maybe reduce it, but we know whenever you reduce something, it's going to get consumed by something else.
Okay. Well, what's a tech summit without talking about AI? Here's a question from Clement in the audience. He says, Supercloud is a powerful, highly scalable, and potentially distributed cloud computing environment. How do you leverage AI with a Supercloud platform?
Yeah, there's two aspects to this. There is, how do you leverage automation, AI, intelligence, or whatever you want to refer to it as? How do you leverage that? That's as part of that management layer, where you've given the policies, the rules, the software, the different stacks within the different stack layers become capable of applying the inference and doing more automated tasks to help offload. So that's just part of continual improvement, where you can leverage that automation that's got the AI as well as other capabilities a part of it. But then there's the flip side to that, which is supporting AI workloads in a supercloud environment. So in other words, instead of AI being an enabler or a functionality that's embedded somewhere in the stack as a part of a supercloud, there is turning it upside down, where one of the workloads is part of AI, or AI is part of a workload that then the supercloud abstracts what's underneath. So for example, being able to abstract the resources for learning and training versus deploying for inference and things like that out at the edge.
Okay. You know, Greg, in your presentation, you talked about how using Supercloud to avoid vendor lock-in can possibly result in another kind of lock-in, and here's a question that addresses that. What can be done to minimize vendor lock-in or stickiness with Supercloud?
Yeah, the number one thing that you can do to watch out for vendor lock-in, stickiness, etc., is to understand that it exists, okay? Go in eyes wide open. Keep in mind that the golden rule around cloud, around hybrid, multi-cloud, around supercloud, the golden rule is as simple as whoever controls the management controls the gold. Okay, now, having said that, and with a little bit of tongue-in-cheek, a little bit of reality, but be aware. Go in eyes wide open. If you know about it, if you realize it, if there is that potential there, One, what can you do to minimize that? Do you need to do any further abstraction? Okay. The other side to it is that a problem? Okay. When I was a customer, it was the notion that vendor lock-in was bad. Okay. Of course, when I was a vendor, it's like, no, vendor lock-in's not bad. Come to the realization that moving out of those two different environments is that it's ultimately up to the customer or whoever's deploying these resources, configuring them, to determine if they're going to be locked in or not. But more importantly is lock-in may not be bad if you are receiving enough benefit from that lock-in, from that potential stickiness, to offset that stickiness. That being said, so it's just one of those things you have to keep aware of, you have to keep in mind. You want to watch out for taking old tech debt and creating new tech debt and just simply kicking problems down the road or creating new problems. So the key thing there is just be eyes wide open, be aware, be cognizant.
Okay. Here's a question asking just how super is the Supercloud? The question reads, how much of Supercloud is just super marketing versus super useful and practical?
This is where there's some deja vu. There's some new and revolutionary with all of this, and some of it's tongue-in-cheek. There is some super marketing. There is some superlatives. You want to just go into a whole rant on putting super in front of things, which we are going to see. That's just simply how the industry works with its pundits and different supporters, and they're going to try to out-super everybody else, i.e. super marketing. But then there is the reality of all this, that there are programs, that there are products, that there are initiatives. There are things that are going on that, whether it be AWS, Azure, VMware, Google, OpenStack, there are different initiatives that are real, that do exist, and we just need to cut through the super, whatever it is, happens to be that superlative.
Okay, we have a couple more questions. Let's try to get right through them. Here's the first one. Is Supercloud just another abstraction layer, and does it have the potential to be another point of complexity?
Yes and yes. And I'll say that is absolutely an abstraction layer and an abstraction concept, an abstraction paradigm, just as clouds and hybrids and multi-clouds have been in the past. Can it be another point of complexity? Well, if we look at the past to see the future, then we have to project out that, yeah, it could be that somewhere down the road, for lack of a better term, phraseology right now this minute, is what happens when we start to have multiple super clouds? Are we going to have to abstract then? Well, common sense and previous insight, looking back, looking forward, would be probably. What's it going to be? I don't know yet. Somebody will come up with something super new.
Okay. Last question, Greg. Does a supercloud mean choosing one vendor or one solution as the supercloud layer?
Not necessarily. Again, this is kind of like a throwback to, do you have to decide on one cloud or another, on one cloud or one layer of the cloud or another? It doesn't have to be. There could be advantages to having one vendor at one layer, at that management, somebody else at that infrastructure, somebody else across the PaaS or across the SaaS or across data protection, that it can be a hybrid approach.
Okay, well, it looks like that's all the questions we have time for. So thanks again, Greg, for an excellent presentation and answering all those questions.
No worries. My pleasure, David.
Everyone else, stay tuned. We're going to take a short break and be back at the top of the hour for our second session of the day, Best Practices for Making a Supercloud Move. So take this chance to check out those resources on your console provided by VMware, and we'll be right back. And sorry about that echo. Don't know where that's coming from.
Hi, everyone. Welcome to the second session of the Supercloud in 2023 Summit. organized by the hardworking folks at 1105 Media Publications, Redmond Magazine, AWS Insider, and Virtualization and Cloud Review, who have brought together some of the best independent experts on today's topic. Many thanks to our sponsor, VMware, provider of virtualization and cloud computing software, and a portfolio of cross-cloud services designed to build, operate, secure, and access applications on any cloud. Without them, this event would not be possible. And thanks to you for joining us. I'm John K. Waters, Editor-in-Chief of the Converge 360 Group of 1105 Media, and I'll be your moderator for the second of our 3 information-packed sessions. But before we get started, a quick reminder that each of today's sessions is being recorded for later access. Keep an eye out for an email with a link to that recording. It'll be coming your way in the next few days. Each of today's sessions will be followed by a 5 to 10 minute Q&A. You can type your questions into the Q&A box at any time. Please feel free to add your questions as they occur to you. Throughout the summit, we'll do our very best to get to all of them. Our sponsors provided some extra resources you won't want to miss. They're available now on your console. And at the end of this the whole summit, you're going to be asked to take a short survey. We know you guys are busy, but we're hoping you'll take a moment to give us some honest feedback about today's event. And last, but definitely not least, at the end of the third session, one lucky attendee will be receiving a Breville Barista Pro stainless steel espresso maker. Oh, God, my skin is tingling, but you must be present to win, so you got to stick with us. Now let's get started with our second session, Best Practices for Making a Supercloud Move. For this session, we've called on Joey D'Antoni, Principal Consultant at Danny Terry and Associates. With more than 2 decades of experience at Fortune 500 companies, Joey is a well-known thought leader in cross-platform IT. He's both a VMware vExpert and a Microsoft Data Platform MVP. He has worked extensively on database platforms and cloud, and he has a high level of expertise in performance tuning, infrastructure, and data recovery. I know you're in for a great session. Take it away, Joey.
Hey, thanks, John. I appreciate it. This is a really interesting topic. When I got asked to do this talk, I kind of laughed because it's been amongst a lot of us who are kind of working in the consulting and analyst space. We talk about Supercloud, and it's kind of a thing that we talk about more than exists yet, but there are principles that are in place. And one thing I want to bring up, since VMware is a sponsor, VMware is a good example of what this can be. Their cloud solution kind of effectively abstracts the cloud you're working on. So if you're deploying VMware on Azure and AWS and Google, you don't really care. Like when you do a migration from on-prem, you can, vMotion a given VM from like one of those workloads to the other, and you're not necessarily concerned about what goes back and forth between the clouds. And that's something that I think is important to understand. And that's like really the goal of in solution of what Supercloud is supposed to be, whether that be VMware or not. It's going to be something that abstracts layers so you don't have to worry about the individual nuances of each cloud. That solution does not necessarily exist yet in one like piece. You can't just go out and buy Supercloud, but there is a lot of investment there, and there are a lot of components to Supercloud, and that's kind of what we're going to talk through. Because of the term super and the fact that I'm from New Orleans and a New Orleans Saints fan, I had to get in a picture of the Superdome. So what is the Supercloud? There are a lot of like various definitions you'll find online, and we'll talk some more about the specifics of what those definitions are. But the general idea is that you have an architecture that combines the benefits of edge computing, multi-cloud, and multi-location computing to create a robust and efficient computing environment. So you're talking about abstracting things. And one of the things that has come up a lot, I think, really in recent months, you've heard from a number of industry people, is about repatriating some cloud workloads. And some of this is done for cost reasons. Some of it can be done for performance reasons. And I think one of the things I think is most important in Supercloud is that it includes some measure of physical hardware and things, because in a truly cloud environment, nearly everything you're using is going to be virtualized. Like AWS and Azure do give you some options to buy bare metal host, but those are pretty uncommon. And for the most part, everything you're working with is going to be a virtual machine. I think for truly like performance-dependent workloads, and these are pretty rare, but this kind of touches on an article I read on Redmond today that I'll talk about a little, or that got posted on Redmond today. When you have workloads that are like, think like you're a gambling site or a big e-commerce retailer, and you just have really high-end, high-level workloads that need extremely low latency, things like high-frequency trading. Those kind of workloads the cloud's just not going to have enough performance for them. But if you can abstract things in such a way that like your developer is deploying those workloads and making application changes, they don't care whether that's not on the cloud, on the public cloud, or in your data center. And those are the things to think about. So when we think about why we would want a super cloud and why we would want to go across platforms, it's not just multi-cloud necessarily. Multi-cloud is part of that. One of the things we've kind of always heard, and it's never really existed, it's something people have talked about, and at least I've never seen it in like a single piece of software. I know people have written scripts to do it and things like that, but is to be able to arbitrate cost across the cloud, right? Across the various public clouds. And that's something that I feel like is pretty key. Also being able to arbitrate security and arbitrate networking. One of the things that frequently comes up whenever we talk about, just doing multi-cloud scenarios is if you're doing any kind of a multi-cloud scenario, there are a few things you have to have that have to have a single home. The most common and the source of everything breaking always, as we always joke, is DNS, right? You have to have a single point where your DNS records are going to resolve. You kind of have like both AWS and Azure, I know, have network solutions that let you have traffic load balance easily between the clouds. The solution in Azure that I'm thinking of is Azure Traffic Manager, where that gives me a public IP address, and it's just a DNS redirection service. I believe you can do the same thing with Red 53 and AWS, but you may have to have another service involved. I'm not sure. But if in a super cloud concept, where is that service located? Is in an ideal like super cloud world, that homing service, like where your front end network layer would be someplace that would be highly available, potentially across clouds and robust, and maybe even abstracted. So maybe you have like AWS Red 53 and Azure Traffic Manager working together to provide some semblance of DNS. So these are all the kind of challenges at just a very basic level we face, to talk nothing more about the implementation details that we face in a multi-cloud environment. So in a multi-cloud environment now, the big challenges, and we'll talk through these throughout the deck, but realistically, the challenges are around having your personnel trained in the nuances of each cloud. The sub nuances, we can go down from there. The networking works a little different. The security's not vastly different, but like the way you implement security is pretty different across the public clouds. So those are all things that like are challenges we have now that in theory a super cloud could alleviate. So when we talk about having that platform extraction layer, like I'm going to go back to VMware a little bit a few times today because it's a really good example. Kubernetes is also a really good example of something that can go cross cloud. It doesn't solve all your problems because it doesn't provide that above the cloud extraction layer. But if you're just deploying VMware on the public clouds, you really are just dealing in vCenter, and you pick a number of compute nodes that you're going to need and how much storage you're going to need. But after that, it really is just dealing with VMware. You're not dealing with each individual cloud. And your billing, in some cases, depending on how you pay for it, is through VMware. So that's kind of the level of abstraction that we like to see. But like I say, the few things I care about, or it needs to tie back to on-prem, and it needs to deliver some higher level offerings. So this is a definition I borrowed from a Deloitte and Touche article that I read the other day. And there's a broad agreement that clouds in the 2020s are different from clouds in the 2010s. So when the cloud first got started, despite in the last session, I think there was some mention of this, in spite of what vendors say, because like vendors will always want to lead with the hype cycle. In the early days of the cloud, we'll call them like 2009 to 2012 or 13. Things just weren't ready for prime time. I'm going to speak to Azure because I know where they were a lot. Azure didn't have virtual machines until 2012. So it was kind of exclusively PaaS in the very early days of the platform. So that's just a thing. Until 2013 or 14, the storage just didn't perform at a level that you could really use it for workloads. So that's something else that really changed. But what happened beyond that is it just got more mature. So we see AWS, Google, we see Azure all moving beyond traditional just IaaS and PaaS solutions. So like things like database as a service or network as a service, they're moving kind of beyond that. And that's kind of what Supercloud aims to do. So it's an attempt to describe that architecture that integrates things like infrastructure, the unique attributes of each platform in software to help solve problems that maybe the public cloud vendors aren't directly addressing. It is a term that catalyzes a lot of debate, conversation, and thought. But the original use of the term is really meant to imply a layer above the clouds. It's generally accepted that customers are using multi-clouds. In some cases, customers are forced by regulatory reasons to use multiple clouds. For the first time this week, I heard a customer of ours, in a vendor RFP, put out a requirement for their vendor to be multi-cloud for availability, which I could get into an argument with you about the perceived availability improvements of being multi-cloud, but I thought that was an interesting thing that it did show up in a contract. One of the things that's challenging about this is each cloud is typically in a multi-cloud scenario operating as a disconnected silo. So you do need those different skills. They have different APIs. You have different development environments. There are some tools around this. So like one of the reasons why people use or are so happy with Terraform is that Terraform is designed to be a solution that can work for infrastructure as code for on-prem, cloud, and any cloud. It's customized for AWS. You can't, for example, take Azure ARM templates and use them to build stuff on AWS, just like you can't use CloudFormation templates to build stuff on Azure. And this means like typically there's going to be some level of friction when you move workloads between clouds. It's hard to share data, move work, secure and govern data. And if you're using clouds for these solutions, some of those things like data governance, those solutions are typically going to be home to one cloud. And there are some other vendors, some storage vendors that have near cloud solutions that are aimed to be multi-cloud. And I think that's also something that's really nice and kind of building towards this notion of multi-cloud where we can kind of seamlessly move workloads between clouds. Remember, Supercloud, especially right now, is not a single technology stack and it's not one product. It's designed the concept is really to create a single environment that allows you to manage workloads across clouds to try to remove that complexity, make application development faster, make your streamline operations, and be able to share data safely across locations. So some of the concepts to dive into a little more detail, this runs as a set of services across more than one cloud. So a consumer of a supercloud can access service elements that run on more than one cloud without requiring specific expertise or knowledge of the underlying cloud infrastructure. I think in an idealized world too, this would be done with a single identity, right? Because one of the biggest challenges we face is identity management across clouds in the way we log in. Like, for example, AWS is very region centric, and when you log in, you get a region specific view of how things work. Azure and GCP are both global specific, so when you log into Azure or GCP, you see everything in your subscriptions across all the regions. So something that eliminates those challenges is something that is going to be helpful. The second part of this is a purpose-built super PaaS layer, and this is that capability that will abstract the underlying primitives of the native platform as a service offering layer in each cloud and creates a common experience across clouds for users, developers, and operating systems. And we'll talk about some specific examples of where some vendors are doing this right now. But one of them is MongoDB, I think, is doing kind of a neat job of this in the way they've deployed their cloud service across clouds. There are a couple of other ones we'll speak to, but where this gets challenging is when vendors start to own, when cloud vendors start to own, and this kind of ties back to the vendor lock-in being discussed in the last session. For example, Azure SQL Database, which is basically Microsoft SQL Server, Microsoft's never going to make it easy for Amazon to run that in the same way they do. So that kind of eliminates some of the options of PaaS services. But one of the main benefits we see to our customers in cloud computing is the ability of taking advantage of some of these PaaS services, like object storage as a service, obviously being a big one with S3 and Blob, but also the database as a service offerings. Load balancing as a service, queue, like all those things that you don't have to build yourself can be really helpful. Additionally, the super PaaS layer will act as a cloud interpreter tailored exclusively for that overarching objective, so whatever you're trying to go for. There's also some layer of cost management that I think has to happen, and this kind of ties into this metadata intelligence. So this is where the Supercloud layer also has to have its own metadata, which also kind of implies that it has to have its own data repository, right? Like it's got to have intelligence and all the stuff it needs to work across the clouds, and theoretically it's aggregating that data so it knows what costs are, because one of the things I would anticipate a good Supercloud to do would be to arbitrate across resources that are considered commodity, right? So if I'm considering object storage to be a commodity, maybe I can optimize for the lowest cost as opposed to optimizing for the best performance or the interoperability I want. So the Supercloud intelligence layer has to have an awareness of cost, latency, bandwidth. So it's got to know, if I'm placing stuff in AWS East US 1A and Azure East US, what's the latency between those? What's the data egress going to cost? What are the security rules? Are there any data sovereignty rules where I can't place stuff? Like, let's say, frequently I see that central India is the cheapest place to deploy VMs in Azure. If my data sovereignty rules don't allow me to deploy data there, my Supercloud layer has to be aware of that. And there are a lot of attributes in those platforms that can explicitly place the data and serve the intended purpose of the Supercloud. So this is something that, as you can imagine, as you start to put all these pieces together in your head, or even just draw them out on a whiteboard, this is something that can start to get kind of challenging, and you might see why we don't have this product yet. You can also see why this product would be incredibly valuable, right? Like this would be really, really useful, especially for larger organizations. But there's a lot of moving pieces. One of the other things that I think is going to be the most challenging aspect of this is you are going to have to be hooked into the APIs of each specific cloud, and potentially, to have an on-prem aspect of this or a physical hardware version of this, you're going to have tools in that space. So I think these are all things that are kind of challenging, but can be done. So what are the benefits of a Supercloud? The first being you can run I didn't advance my slide. Sorry about that. The benefits of the Supercloud, you can run physically on different clouds or on-premises. I think the on-premises aspect, especially for large organizations, this is a really important component of this, because there are going to be some workloads, especially high-end workloads, like if you're running something like SAP, big database servers, those things are probably going to be more cost-effective to run on-prem. And in some cases, for some organizations, it may make sense to run those in the cloud, depending on what your plans are. But if you're retaining data centers, it can definitely be more cost-effective to run those in a hybrid fashion. And I think giving a seamless experience to run those things in a hybrid fashion is really important. The other thing you want to see is things that are able to operate cross-cloud, like security, operations, and governance. One of the things we see that I've really enjoyed about cloud computing, and I think it helps a lot, and this really applies to all the cloud providers because they all have similar offerings in this space, is that we have the ability to understand workloads and have metadata around workloads, and that just using things like tagging. But that goes a step beyond that. We have governance features like policies, so we can limit the kind of things that people are doing. So we can, as IT organizations, you can have more control, and you can even take that up a level into the business. And it provides costing, right? So when I worked at Comcast, I basically 60% of my job at Comcast for the 3 years I worked there was trying to understand what everything cost and building data models around costing resources. And as you can imagine, in an organization that large, two of our data centers were like standalone data centers, which made it really easy for me to get, I could figure out kind of down to the CPU how much power and cooling cost. Well, it turns out one of our biggest data centers was attached to one of our larger offices. So that made it kind of tricky to better understand what that cost, because what power and cooling came from the building and what power and cooling came from the data center. So I think having costs associated with this, with like real values, is something that's also all the cool stuff that we get in the cloud, like FinOps. That's something that's got to be part of Supercloud and going across wherever you're running and bringing you a single rollup. All this always relates back to a data problem, which I laugh about because I do data for a living. But with those capabilities, you're able to provide more optimal solutions. Should also help you optimize cost and allow you to use best-in-breed solutions. This is a notion of multi-cloud, but I think it's also something that, as we talk about Supercloud, is kind of important because first of all, you're able to reduce replicated services. So you're trying to just reduce the redundant services in your environment. And if you're kind of arbitraging costs for those services, you may take a look at that. And by pushing that layer into above the cloud, you're not as concerned about the specifics of your implementation. The best-in-breed solutions parts, like I said, a notion of multi-cloud, and this just allows you to potentially take advantage of a PaaS service that's more suitable for your workload than others. It does help you reduce single points of failure. You're no longer, hopefully, wholly dependent on the health of Amazon US East 1A, like half of the internet seems to be. I'm always hesitant to recommend multi-cloud as a disaster recovery strategy, but if Supercloud is kind of the idealized implementation of a multi-cloud environment, then you might have the case of being able to take advantage of those reduced points of failure. And then finally, and I talked to this earlier, but governance, FinOps, and security can all be surfaced above the cloud. So the challenge with multi-cloud now and doing this is each of those things, for the most part, are individualized in each cloud. So Azure, AWS, GCP, they all have governance, they all have FinOps, they all have security. They all kind of mostly do the same thing. They all do role-based access control. They all offer you budget insights. You can alert on budgets. All of those things are pretty common across the clouds. But the difference here would be if you're doing it in one centralized above the clouds location, you don't have to worry about the nuances of each of those things. You can just simply have it, and it's kind of awesome. So some of the current Supercloud challenges. I'd say I think the biggest Supercloud challenge, and I was talking to John with this before he came online, is that there is no product that does all this yet. So you can use VMware, you can use Kubernetes, which we're going to talk about later. There are some products that are Supercloud kind of on their own that are offerings, and I think they tend to the ones I'm mostly going to talk about tend to be in the data analytics space. Like Mongo and Mongo is not really analytic, but Snowflake and Mongo. Those vendors, you'll note, are kind of not. Snowflake's a cloud vendor, but they don't have their own cloud, and Mongo is a database vendor who also doesn't have their own cloud. So they're more apt to not try to protect their market and do those interesting things. I think for Supercloud to be ultimately successful, there's going to need to be a vendor or a consortium of vendors that do all this. But it's going to be really challenging, and these are the reasons. And the first is that different cloud providers have different security models, which means and the APIs work differently, which means anybody who's building a Supercloud, your deployment layer, even if you're using something like HashiCorp Terraform, right, to deploy that can go cross-cloud, cross-prem, you have to figure all that out. And those APIs change, not like all the time, but they change enough that it's a little bit painful. And when you roll in, so let's say we were building our own Supercloud software and we wanted to take advantage of Terraform. When Microsoft changes an API, Terraform has to change, and there's latency involved in that. So you're not kind of constantly on top of those things. So this is something that's always a challenge. Surface area that needs to be secured, and this is just kind of a natural thing. As you're using multiple clouds, as you're using your own data center, even if you're using multiple data centers, that's more stuff you have to worry about securing. Ideally, the Supercloud is going to handle this for you because it's going to know the best practices on each cloud, or at least be able to interpret maybe the best practices recommendations that each cloud makes and limit you from doing those things. The third, in my opinion, is probably the biggest challenge, and the FTC recently put out a call for things that are causing non-competitiveness in cloud computing. And this was one of the biggest, and it's data egress cost. If you're not familiar, all the public cloud providers, and this may be one of the first times I give Oracle credit, Oracle's definitely got some more friendly policies on this in their cloud, but all of the public cloud providers charge you, let you ingest all the data you want into the cloud, so you can put however much data you want into their cloud. But when you remove it, it's metered, and you get like 10 gig of traffic free a month. And after that, it depends on Amazon versus AWS or Azure. Sorry, what the rates are. Like Azure is, I think, 8 cents a gig a month, and there's a sliding scale, and it goes down. But if you're talking about having like petabytes of data in the cloud, this can be something that's a challenge. Or even if you're like transiting terabytes of data a month between the clouds, this can start to be a significant cost, and this can be a real challenge to data egress costs. So this may be something that's handled by legislation. I think one of the things the cloud providers are doing is hiding a lot of their profit margins in data egress, like they'll lower costs on things like compute and storage, and they have to make up for those lower costs somewhere, so they make up for it. They make up for it in data egress costs, potentially. There's been a lot of discussion about this. And then finally, the last topic is data governance. And really that comes back to that metadata layer that I discussed earlier. Because this package of tools does not completely exist, we don't we don't necessarily have one single set of solutions that provides us this nice reporting layer where you go to supercloud.com and you can log into your account, or maybe even your domain.supercloud.com, log into your account and see where all your data is and all that. So keep that in mind. So what's new about Supercloud and what's now, I should say, not what's new. The concept of Supercloud isn't just multi-cloud. It goes well beyond that. I think, and if you ask me what I think the differences between the two are, it's that multi-cloud is kind of arbitrary, and you're just kind of splitting resources between cloud providers, maybe for cost benefits. What Supercloud is a layer that's built on top of that. It hides that complexity, exposes differentiated service capabilities, and gives you like a new business that goes beyond just the Lego bricks of the existing public and private cloud. So it hopes to eliminate, you hope to eliminate that complexity that face developers and business. However, there's still some vendors that have a good concept and have good tooling. I think, honestly, the VMware solution is very good. I know they're sponsoring this, and I'm a vExpert, but they don't compensate me or anything. I like their solution if you want to be able to run in a multi-cloud fashion where you don't have to understand everything. You also want to talk to your software as a service vendors and understand what they're like. I think software as a service and how it's going to integrate into the Supercloud solution is kind of interesting, because if you're using something like Salesforce, or even if you're using something like Office 365, like using Office 365 inherently ties you into Azure a little bit, because even if you're not using Azure for anything else, your authentication has to take place there. But I think it's a good question to ask around your SaaS vendors, like how are they going to work in a Supercloud type environment? This space is still pretty immature. Like we're talking about things. I'm talking about a lot of concepts here and what an ideal world would look like. And there's not a single solution you can go and buy today to do this. One of the other things is you want to think about designing for your overall architecture and not individual apps. So you want to shift the focus from like a micro level where you're looking at each application that's owned or operated by IT, more to like the macro level where you're looking at the value of automating and digitizing your business networks and what their associated data workflows are. Like you're going to inherently have distributed and decentralized applications. So it has much higher demands from the plumbing and infrastructure that it runs on. It also kind of implies that decisions about multi-cloud and cross-vendor technologies have become a mission-critical CIO level decision. Supercloud's another layer that we have to worry about and just thinking about. So challenging, not mature yet, but with a lot of potential. Sounds like a lot of other things we've talked about in IT, but I think this is probably going to happen just because of the layers of demand for it. So some examples of some Supercloud workloads. And I'm going to give kind of examples for each of these. Analytics, so Snowflake is a really good example of a Supercloud workload. You do pick which cloud you run in, it's abstracted from you, right? So Snowflake, all your interaction is with Snowflake. And the way they're optimized for data sharing, governance, query performance, their security model, enablement, and even monetization. So you can monetize your own data with Snowflake, and they really have done a good job of extracting the cloud bit from what you need to do. So I think that's something that's kind of interesting. They've been pretty successful with their offerings. I know I have several friends that work there, and I think it's a pretty nice solution about where they've gone. Converged databases, this is another example, and this is also kind of the topic that we call HTAP. So running transactional and analytic workloads on a single database. The common example of this is Couchbase with their Capella offering. In Couchbase, Capella lets you stretch the cloud to the edge. You can run on edge devices, you can run on the cloud, and they've optimized for low latency across clouds via synchronization capability. So that's something that's pretty cool. Couchbase is mostly a key value store, but also kind of a document store. Document database workloads, so MongoDB, this is a very developer-friendly platform, and they have a cloud offering called Atlas, where they move to the Supercloud model, running document databases across clouds very efficiently. They accommodate analytic workloads, common developer experience across those clouds. So your developers, no matter where they are, they get the same experience. Data science workloads, and this is specifically to Databricks. If you use Databricks in Azure versus Databricks in AWS, there are kind of some minor differences, but for the most part, the developer experience is very similar. And this emergence of data lakehouse and data sharing is a place where they've done this well. For general purpose workloads, I'm going to refer back to VMware. They've built a common operating environment across clouds, and it works in the edge, it works in your data center. It's just VMware wherever it is. We'll see where that goes in the future with this acquisition, but I think they've built a really nice groundwork that lets you to, move workloads between clouds or back to on-prem as you need to easily. And then finally, network routing. So there's a company called Aviatrix that is what they're trying to do is build a super cloud to optimize network performance and automating security across clouds. And where I think this is going to go is that, like, you may have a few of these companies, right? So you may have a network company like Aviatrix, you may have Snowflake, or you may have Mongo, and they're going to build services that are going to kind of run on top of these clouds. I still think the governance layer is something that's really kind of critical, and you should keep it in mind. So Supercloud and how to implement. This was about implementing, and it's hard for me to describe implementing something that only kind of vaguely exists, but I'm just trying to give you guidance based on my years of experience in working with cloud and where I kind of see this going. One of the most common things we hear about when we talk about multi-cloud or any of these sorts of solutions is Kubernetes. And the reason for that is Kubernetes is kind of like a lowest common denominator, and it's a pretty cool solution. But it lets our developers have one common deployment experience wherever they're deploying, right? If they're deploying a pod on their laptop, if they're deploying that same pod to a physical server, they're deploying it to a hosted Kubernetes solution in Azure or AWS, that's all the same. And we can kind of relatively easily set that infrastructure up. Like, it's pretty easy to have Kubernetes running across clouds. It's not just that simple, though. Like, it's not just getting workloads to run across clouds, like my last bullet point. This is not simply multi-cloud. It's really that big metadata abstraction layer that we're talking about with Supercloud. And when that comes to fruition, that will be where we're really deriving the value from, not just the notion of like having, web servers in each cloud to be able to, either save a few bucks or be available in the event that Azure goes down. There's no one size fits all to this yet. I don't know that there ever will be. I think in order to do this, I think it's too big for one company. And I think the only companies that are big enough to do it are probably one-off by themselves, rather, or like Microsoft and Amazon or Google. And they're not going to build something that really helps you work across clouds easily. So I think it's going to take kind of a consortium of firms to build a set of tools, like I mentioned on the last slide, that will do this. But whatever tooling is involved should really, reduce or eliminate the subtleties of each cloud, because that's by far the biggest hamper to multi-cloud, is just that everything's a little bit different. Just today, I'm doing some testing in AWS for a client of mine, and I ran into a really stupid thing that I didn't realize happened on my VM deployment, and it was just me being dumb. But it's something that wouldn't have happened on the other clouds, and those subtleties are kind of different. And like even just like networking, the thing I'm working on involved Windows clustering, and the way I had to implement Windows clustering in AWS is very different than the way I had to implement Windows clustering in Azure. And that's a real basic example of something that's like annoyingly different between those two clouds. But if I wanted Snowflake and Azure and AWS, I wouldn't have to do any of that. So I think getting there and getting to that point is really kind of important. This is all just really kind of conceptual right now, so it's kind of funny. If you're a big enterprise, you may have the notion that you can build a Supercloud solution, but I hope you've kind of learned that like it's really above a layer above what I think can be pulled off in enterprise IT. And don't get me wrong, I know enterprise IT organizations can do a lot of really awesome things. Like when I was at Comcast, we built our own private cloud, and it's a project I'm still pretty proud of. But this is something that's challenging, and it's going to be in kind of an ongoing development effort as long as it exists. It's a multifaceted project, and it's also something I don't think is a great fit for an open source project either, because even though I think a lot of the code could end up being open source, I think it needs to be driven by a company that wants to make money on it, because there are a lot of value added benefits, but it's just going to be a lot of work as I've been describing to you for the last 42 minutes or so. The cloud providers will not build the Supercloud. I would be shocked if that happens, just because it's not in their vested interest to get you off their cloud. We talked a little bit, or you heard a little bit earlier about vendor lock-in, and yeah, the clouds definitely aim to get you locked into their cloud, or even at least their stack, right? A lot of them have hybrid offerings where you can take advantage of stuff running in other clouds, but they want to get you hooked into their software stack. So while they may build stuff to let you manage resources running on other clouds, like Azure Arc's a good example of that. I can manage VMs running in VMware or AWS. It's still hooking me back into Azure. It's not going with that above the cloud approach. So the solutions are likely going to come from software providers. I feel like, and unfortunately, I don't like the direction they're headed in, but I feel like Red Hat would have been a good prime early Linux building. Red Hat would have been a good organization to build something like this. MongoDB, Databricks, and Snowflake really do provide a good roadmap amongst other firms, but even then, they're still not. They haven't built necessarily an above the cloud layer. I think Snowflake's probably the closest to that, where you have data sharing easily across clouds. It's just kind of not there yet for true supercloud notions. So supercloud is complicated. If you were all sitting in my office right now and we had a whiteboard, I'm pretty sure my whiteboard would be filled with just the things I've described, and I'm sure you're going to ask me some great questions about what other requirements would have for Supercloud. Feel free to chime in those questions now. There's not one complete story from any one vendor or even any series of vendors. You have networking vendors, you have VMware, you have the data vendors. The presence of the cloud providers and who they are and the fact that they're kind of software companies, I think adds additional layers of complexity to this. It's not just Kubernetes, it's not just multi-cloud. So don't think of the notion of supercloud as just being, multi-cloud V2. It's really not. It's that above layer where you're abstracting everything and it becomes your total management layer. There is a lot of investment in the space because it is so promising, and so many organizations do have the need to be kind of multi-cloud or in multiple clouds, and having one operating layer, one single pane of glass to do all that is obviously something that could be a highly profitable endeavor, even though it's going to cost a lot to build this. And as always in software, stay tuned. Things will change rapidly. And I just want to say I didn't mention the words AI during this talk, except now. But I hope you all enjoyed that discussion of what to look for in Supercloud. And I think it's a really cool topic. I think it's going to grow a lot in the next couple of years. And we'll see where we go. And John, do we have any questions?
We do indeed. And thank you for not AIing. Okay, here we go. I want to remind everybody that you can still type your questions in the Q&A box. We'll do our best to get to all of them. Let's start with this one from Annie, who's wondering, what would be the networking concept for Supercloud?
So my vision for how this would work would be effectively like a multi-cloud solution or even a multi-data center home solution that was provided by a network provider that maybe had its basis in the cloud and not in the cloud. So it would be tolerant to failure. So if you had the notion of having that global DNS or that global load balancing for an app that's running across all three clouds, the networking layer would be separate from those clouds, but maybe have redundancy onto them. I think a lot about networking when we think about any of these solutions, these complicated solutions like this, because everybody's always like, oh yeah, blah, 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 you can just do this. But you have to make the wire, you have to connect the wires to make everything talk. And you want to make sure everything works if one wire breaks. So I think having that like kind of somewhat distributed fault tolerant layer that runs in a bunch of different places, almost the kind of concept I think of is almost like a content delivery network, but for networking.
Mm-hmm. Fascinating. Okay, here's one from Zeke who's wondering, what apps build on Supercloud?
We talked about a few, and I just want to touch back on that. I find it kind of interesting, as I was putting this deck together, I find it interesting that so many of those firms are data firms. And I think part of that is those companies have built up good businesses that are just kind of away from the cloud vendors. So Snowflake's probably the closest to the cloud vendors because they're cloud exclusive, but Mongo and Couchbase and Databricks, they've built up these cloud independent data solutions. And one of the things that this actually came up with a client the other day, we were like looking for a way to run a Spark, hosted Spark on-prem, which is effectively what Databricks is like. And that's something that doesn't even exist in an on-prem world right now. It's kind of interesting. So like Databricks in cloud is your managed Spark offering. So I think those are all kind of newer companies that were built on top of the cloud, but not with full dependencies on a single cloud. So those vendors are all aware of the nuances of each cloud, and they're profitable companies, and they've been able to kind of build those things. So I do, like I say, I find it interesting that they're kind of in the pure cloud space. Of course, VMware, not to take anything away from them, but it's like kind of just VMware, right? So they just made VMware work. It's not like they built a new offering, whereas those other offerings were built on top of the cloud to begin with.
Here's kind of a long one from Drew, and I hope I'm going to try to get this right, of course. With the introduction of MySQL HeatWave, that's the database service, which allows ACID and ACID and analysis operation at the same time with object storage, in other words, cheap, is it easy to manage HeatWave? Easier, must have meant easier to manage HeatWave than other databases.
I think you run into HeatWave is a cool product, and I think the notion of using object storage for database storage is kind of interesting, especially for analytic workloads that maybe don't necessarily need the lowest levels of latency and performance. I think that's a cool concept. It is something, MySQL is MySQL. It's an open source database package. I mean, HeatWave is kind of owned by Oracle, so that does make that part a little bit dicier just because everybody freaks out about Oracle and licensing. I think the notion of managing it's going to be mostly the same as managing MySQL. Where that could fit into a multi-supercloud scenario, if they can make that work across clouds, Where that would be imminently challenging is like, how do you stream data from S3 to Azure Blob, or even like if I have a storage array at my data center that has an object store. I guess if that storage array talks S3, maybe you can stream data, but I think that's where that would start to get complex.
You will wrap up with this very straightforward question. Joey, is anyone using the Supercloud yet?
I would argue that you could say Snowflake and probably Databricks are. But they haven't exposed. Snowflake's kind of a really interesting company that I wonder about. And like I say, I know people there, but I don't have an NDA with them or anything, so I'm just going to speculate. I think they would be an interesting company to build a Supercloud offering because they have to deal with all that. Their customers don't see it, but they're dealing with every cloud provider. They know what the network looks like. They know what the APIs look like. They know what the security model looks like. I think if they think there's profit to be made there, I think that could be an offering. I would not be shocked. It goes away from what their core mission is, I will say that, but I wouldn't be shocked to see them do something in that space just because it's, I think they're of all the vendors we talked about, I think they're the one that's the most aware of that and has the most level of interaction with all the clouds. So I think that could be an interesting play.
Looks like that's all the questions we have time for in this session.